Okay, so now we are moving on to section 9.2, which, as I previewed yesterday, is all about confidence intervals for slopes. So remember, we are attempting to estimate the population slope for a linear regression. And remember, the general form for a confidence interval that's given to you on your formula sheet is the statistic, so the sample of your population slope in this case, your b-value, plus or minus a critical value. In this case, that's a t-score, like it was with means. We're using t-intervals here, times the standard deviation of the statistic. And so for our confidence interval, this is the b-value, right? That's your slope, your sample slope, plus or minus our t-score that we get from inverse t, times the standard error of your slope b. All right. And that's broken down here down below. The big thing to remember is that t is a t-score found using inverse t with n minus 2 degrees of freedom because we have two variables. And so here's our data that we discussed yesterday where we're comparing the row that a student sits in and a score that they got and the same computer output that we were given yesterday. Assuming that the conditions are satisfied, answer the following. So give the standard error of the slope and interpret it in the context of the data. So standard error of the slope is 1.332. And it is the average amount that the sample slope is off by. Right, so if we knew the population, then our sample slope of negative 1.517 would be off by 1.332 on average. Right, the critical value for a 95% confidence interval. So remember, this is inverse t. When we do inverse t, we have to put the area to the left. That area to the left for a 95% is 0.025. And then we have n. We have a total of 30 students minus 2. So we could just write 28 degrees of freedom. Remember, to get to inverse t, we go to second vars. It is option 4, 0.025, 28. And we have negative, so plus or minus 2.05. All right, so then using our formula, we're going to take our sample slope, so our b value, negative 1.517, plus or minus that 2.05, the t value, times the standard error of the b value, 1.332. Well, that'll be negative 1.517 plus or minus 2.05 times 1.332 is 2.7306. All right. Well, that'll go from, negative 1.517 minus 2.7306, negative 4.2476 to positive 1.2136. Okay, and so to interpret this, we would say we are 95% confident that the population slope for score is between negative 4.2476 and positive 1.2136. Okay, now that is confusing because that shows us that it's possible that your score could go up, right? It could increase if the slope is positive, the further back you get, right? There's a lot more of the interval in the negative, but this means we're going to have trouble making a conclusion here about what the row a student sits in really does to their score. All right, we're going to do one more together. A thrill seeker wanted to try to travel across a large field while being suspended in the air by holding on to balloons. In order to determine the number of balloons needed per pound of weight, he did a preliminary study. He selected a random sample of 20 rocks of various sizes, weighed each one, and also determined how many balloons are needed to lift the rock. Here's the output from a least squares regression analysis of the data. Okay, now I just want to review the conditions that we talked about yesterday because they're important to discuss. So L, remember it was LINER. L says that your data must form a linear pattern. Here we have a scatter plot, seems to form a linear pattern, so L is good. I would be independent. Independent is checked off if your sample size is less than 10% of your population. 20 is absolutely less than 10% of all rocks. Normal. N, normal is your residuals, right? Our residuals have to be symmetric or evenly spread out. In this case, that's a little bit challenging to see because here we've got a dot plot of our residuals. So we can't really see the shape except to say that each residual only seems to appear once, which is not normal, right? And so we're going to sort of question mark that one. E equals standard deviation. We do seem to have a pretty balanced look at our residuals and our residual plot and our random sample, which we had. All right, so that N is the only one we're not sure about, but we are going to proceed anyways. So construct and interpret a 90% confidence interval for the slope of the population regression line. Well, looking here, we've got our sample slope under coefficient, our sample y-intercept, our standard error of the slope, right? We only need these two to do our confidence interval. We're going to start with our sample slope of 30.4126, which would tell me that for every 1 pound of weight, the number of balloons needs to increase by 30. Plus or minus our t-score, right? So we're going to use inverse t with an area of 0.05 because we have 10% total. We did 20 rocks of various sizes minus 2 because 2 variables is 18 degrees of freedom. And so our critical value is 1.7341. So that's 1 times that standard error, 2.0416. All right. So this will be our sample slope, 30.4126 plus or minus 3.5403. Is 26.8723 to 33.9529. So we'll say we are gosh, guys, I'm sorry. 90% confident that the population slope for number of balloons is between, I'm going to copy and paste these values. And Okay. All right, so go ahead and work on the exit ticket. Make sure you're checking the key to ensure your understanding. But hopefully this is a pretty easy follow the formula, plug numbers in, and interpret.